This is the real life examples of what we see. Engineer tried to change the 2 to a 4, but instead of changing, they added the 4. That is the only difference. And then what happens? That goes to production as someone comes and screams at us. And it's like, hey, how did you spend this much money? What happened? I'm like, there's nothing in here. And this is like the smallest block of code. Imagine a pull request which has got thousands or hundreds of lines of code being changed. How do you do this?
My guest today is Hassan, founder of Infracost and a governing member of the FinOps Foundation. He has been doing cloud costs for 17 years, and he shows me live on screen how engineers catch these mistakes before the merge. We get into the 10 million price points that make cloud pricing impossible to memorize, an AI agent writing infrastructure with costs baked in from the first line, and how AWS charges you 600% more just for running an old EKS version. If you write Terraform, review pull request, or own a cloud budget, this one will change how you look at your next diff. If you are new here, subscribe to Engineer. We bring on people like Hassan who actually build this stuff. Let's get into it. Hassan, welcome. Really excited to have you with us today. So for those who don't know you yet, so you are the founder of Infracost. We will be talking about it, which is, I believe, the most used IAC tool for shifting the cloud costs left. And I will be talking about all of this. And also, you are a governing member of FinOps Foundation. That's yes. A very exciting position. And I have a lot of questions to ask you about this.
Good.
And you are a repeat entrepreneur. You already built other companies before. And you have been around like for 17 years or so in the industry. And I believe you are one of the best people to talk about everything costs in the cloud with AI and all what's going on. So
I appreciate it.
Absolutely. I would love to complete the intro for anything that I missed.
You're building up the hype way too much. I feel like we should build it. No, but good to connect. We've known each other for a long time now. We've known each other for years and years. So good to connect. I'm Hassan, one of the founders of Infracost. Good intro. So because my first ever startup was about 16 years ago. And what that product used to do was what we used to call cloud cost management. So my first startup was in this space as well. Okay. And so what we used to do is basically take the bill from AWS and you put it into charts, you show it back to people so more people can see it and what's happening in there. And what we learned long-term was kind of like, oh, that's like reactive, right? By definition, if we're looking at the bill, that means the engineers have already launched the resources, gone to cloud, it's running live, and then we see it. So by definition, anything we're trying to do, we're trying to fix retroactively. And that's the problem. Like there was like, all right, we need to solve this at some point. We couldn't fix it back then. So things have changed. We can fix it now.
Yeah, that's a very interesting point. I mean, I was thinking about it, like what's the proactive versus reactive way to deal with the costs and how you inject in the feedback loop, like what you learn that the engineers can take it into consideration. But let's start with the basics. Like if you can walk us through like what are the cloud costs, the general concept, and what the engineers need to know about the costs when they are building cloud infrastructure. Then we can talk about like shifting left and going into like in the nitty gritty.
Let's do it. Okay, so it's cloud costs in general is an incredibly complicated space, meaning from the cloud providers, there is a lot of services that they provide. Each service is priced very differently, even within a cloud provider. So for example, if you look at S3, it's priced very differently to EC2, to other things. So there's incredibly complexity in the pricing itself. Now, if we step back from that complexity and we look at the entire thing as a formula, I think this is very helpful for people to start thinking about how do I decouple information so I can act on it, is cloud costs equals usage multiplied by price. Pretty basic there, but it actually is very interesting in those two parts. So if we look at usage, that is what services you use, where you use them, how you configure them. So very much engineering decisions. Like you will make, I'm assuming majority of audiences here is engineering. So you'd make those decisions on how the Terraform is written, how the infrastructure as code is written, like what do I need to use and what do I need not to use. Multiplied by price. Price is another entire dynamic, which is negotiated rates, reservations, savings plans, commitments. There's a lot of things like that. Those ones, you can start to think of them as like financial risk mechanisms. And what I mean by that is, so for example, you can say, hey, I will buy this EC2 upfront for 3 years and I'll pay upfront, and I will use this for 3 years. Naturally, the way you got to think about that is the risk towards when you might not use that service anymore and how much you've paid and what the break-even point is. So the on-demand price could be $1 an hour. The savings rate could be 50 cents an hour. And so how many hours of usage do I get out of that for that to equal? And anything above that is profit. So you can see how you got to start thinking about it very differently, right? Which is like a financial model analysis. Who knows what the next version of the chipset is going to be in a year, 2 years time. So you've got to take it into account at a much higher, broader level. So if you think of that, cloud cost equals usage multiplied by price. Usage is engineering. Price usually is done in a central model from a finance perspective, from a finance background where you're looking at those models and things like that.
And so when I think about it as an engineer, like at the ground level, I build cloud infrastructure, I deal with the services, and I have a budget for the infrastructure or for the project I work on. So what could be, like as an engineer, what are the things or mechanisms that I have that I can leverage to be able to shift left? And I would love also your definition of the shift left. We know what shift left means, but for the costs. How I deal with it as an engineer?
Great question. Okay. Let's break it up into 3 parts for an engineer to do. There's 3 main critical points at which engineers get involved and can do something about it. I'm encapsulating architects in engineering as well.
Yeah.
So the first part is architecture. When you're actually deciding how the system is architected, you're making some decisions about costs for sure. Like, hey, do I use a serverless function? Do I use EC2? Do I use Kubernetes or whatever? So at the first of the part, and this is where we connected a long time ago, which is when you're defining that architecture, it's important to think about cost as well and how that architecture sets up. So that's stage number 1. Stage number 2 is when you're actually coding it. So when you're actually going to the details of what the service is, what size of instance, what size of service, and things like that is being used. And the third part is post it's gone live and you're seeing how it's performing. Because at the first 2 stages, you usually can't see the real performance. You can guess, but you can't see. So it's only at the performance comes on the later stages. So as an engineer, depending on which part you're sitting in and which part you're actively working in, the first 2 are by far the most important. And it's natural to think about it this way, which is like, imagine a database. Super simple. I spin up a database. While there is no data in that database, I can do a lot of stuff. I can change it. I can like edit it. As soon as I have the first record in the database, all right, now we've got migrations. There's a step function immediately that happens that becomes harder. So there's a lot of decisions you can make at that point of like from an engineering perspective of how to optimize this stuff.
And this is proactive, right? This is like before I go live and before the usage. Okay.
Yeah. And this is where the shift left is mindset comes from.
Okay.
Right.
So the way I understand shift left is that you need like a short feedback loop that allows you to know if you are right or not. Right means you are respecting the budget, you respect the policies of the company, you are allowed to go to prod based on the criteria that we put in the path. And if not, we tell you exactly what's wrong.
Yes.
So if we apply it to the FinOps, it means at least I have some awareness about the costs and how they fit within what I'm building. But as you mentioned before, you have the usage multiplied
Mhm.
by the price.
Yes.
So how the combination of both fits in the shift left?
Okay, so let me clarify one thing. So it's usually not just um, the best practices from the company, but it's also the well-architected framework and things that the cloud providers do that are hidden towards the engineer. So it's not always like oh, the company has said we should stick to this budget. It's actually things like, I'll give you an example. If you use EKS and just been using EKS for a long time, you're using a specific version of EKS, you might not change anything or do anything. However, AWS now has something called extended support. What extended support is, if you use an old version of EKS, they will charge you up to 600% more. So it's like, all right, we've got to tell the engineers that. You can't hide that from the engineer and make AWS more profit. So if I'm writing that code, so that's the kind of best practice I'd say comes into shift left as well.
Okay.
So let's talk about the usage. Exactly right, right? Where pre-launch, imagine there's no service out there, and so what do you expect the usage to be? And this is how a couple of companies think of it a little bit differently depending on who they are. Some companies think of it as, hey, I want the engineer to put baseline minimums in place. So we can say, hey, if you're using an S3 bucket, I want you to think of it as a baseline minimum of 10 gigabytes, because that's probably what's going to happen in the first 2 weeks, 3 weeks, or something like that, and make decisions based on that baseline. However, other companies who are more forward looking, they say, actually, I don't want you to look at S3 as it is right now. Because it's going to production, I want you to think of it as in 3 years down the line. And in 3 years down the line, it's going to have a terabyte of data in there. So any cost estimation that you do, I want you to show about a terabyte of data, either being data transferred into it or S3 buckets. So the decisions that we make now are long-term decisions. And we have this thing called the usage file. I can show you as well. And these are the configurations that you can set to shift left and have estimations pre-launch.
Okay. So yeah, all right. It makes sense now.
Yeah.
Yeah. And yeah, and back to the to the FinOps. I know that now it's a whole concept. It's and there is a new concept tokenization around tokenization and so on. So if you walk me through how it gets started, the FinOps, and how at some point we thought, okay, we need to create a foundation for FinOps and name it FinOps, and
Yeah.
it's a movement that it's not just as we said, it's not just about finance, but it's engineering behind the scenes.
Yeah. So let's go back. This place used to be called Cloud Cost Management back in the day when we did our first startup. And basically what the practice came to be is the basis only from public cloud. So it was only AWS, then Azure and Google as well. And it was actually back in the day was SoftLayer, and there was a couple of others, of how much are we spending in cloud? Where's the money going? And things like that. And then it evolved from a visibility perspective, because it changed basically from a CapEx model where you buy servers to an OpEx, which is operation, literally every month you're getting charged. So it went from a place where we're like, hey, we need to start predicting this stuff. We can't just spend unlimited amount of money. So a small formation happened of how do we provide visibility? Where's the spend going? And things like that. Naturally, when you provide visibility, what happens? How do I optimize it?
Yeah.
So you see it, then you go oh, wait, I can do something about this. Why are we spending so much? Why is it growing so much? So then you can start to do something about it. And that's where optimization started. So fast forward, as more and more production systems came on, scaled up into this from a private cloud to a public cloud, then it became bigger and bigger dollar values that are interacting with this, and more people got involved. So it wasn't only a couple of engineers who are using cloud and the finance who has to pay the bill. It went into, wait, you're architecting it this way. How am I going to architect it for highly available systems? Because it's production now. Well, that has a cost now as well. So now you've got 3 people. Procurement gets involved. It was hey, if we commit to $2 billion spend per year, what discount do we get? So that's procurement, negotiations, legal, and things like that. So it just started expanding into a place where it needed a framework of people having common language and to learn from each other the best practices, and the complexity kept growing. That's the start of like where FinOps kind of came to be.
Okay. And so, and if implemented correctly within a company, who would be involved in that case? Because you mentioned like 3 or 4 personas from technical to non-technical.
Yes, exactly. So there's actually more. There's, I think, now 8 personas, different personas that are involved. But it's a FinOps practitioner. It is finance. It is engineering. It is architecture. It is C-level executive sponsorship and support, because some of these things will require top-down movements on like how do we do these things. Some side, I think if you go to the FinOps Foundation's website, there's some side personas that are also involved now, which are things like environmental impact, so green ops and things like that. They're appended, because if you reduce costs, you usually are reducing carbon as well. Not always, but usually. So there's a bunch of those personas that are now involved as well. But the key ones on the usage component anyway is engineering. And so this is an incredible place for engineers to make a mark on this industry, which is get involved and see, here's how I'm going to optimize it, because you hold the keys to the actual action. You can have the visibility, but the action is where the value is realized, where you actually change something and you reduce the cost. And it's an incredible place to be.
Yeah, amazing. And so I'm talking about the engineers, like there are a lot of tools out there, and sometimes it's overwhelming when you see that, like the tools from open source to enterprise and closed source and paid software. So in terms of ecosystem, so what engineers really need in terms of tooling to be able to do their work with FinOps awareness, and the most important part for me is also how to measure it, how you measure the return on investment.
Yes, great question. Okay, completely agree. Look, let's expand the scope of the question. Not only for costs, but look at the things we're shifting left. And at some point, it's like, if you're shifting everything left, like when is the engineer going to actually code? Or is it going to actually write something? I think it's critical for these tools that are going to shift left, regardless of cost or any other tool, any other space. I mean, they have to be directly integrated into their workflow. It cannot be adding overhead. It cannot be noisy. And these are the things that we've learned over the last 5-6 years. It's got to be fast. There's I think there's 9 key points that I've wrote about, which are like, these are the things that you need to do to make sure the engineer is more productive, not less productive. And these need to be incorporated into any tool you buy, regardless of open source, paid, commercial, whatever. It's got to be these things that are being integrated. I'll share that with you so we can publish it as well.
Yeah.
But in terms of shift left, do you want me to show you? Do you want to see what I mean in terms of
100%.
like, here's actually...
Yes,
because
I mean, I feel like people, and I feel more comfortable on the technical details.
Oh, I love it. Okay, so I'm gonna share my screen. Oh, wrong button. There we go. Share screen. Move you over here. Alrighty. Now if I go to slideshow, will that work? Perfect. I'm gonna put you on the spot here. How much is this bit of code going to cost? This is a bit of Terraform, right?
Yes.
It's got some services in there. How much is it going to cost?
Okay, it's scary when I see Oracle. Come on, a lot of
Oracle
money.
app scares me.
Yes, because Oracle is like, you have 6, 7, 8 digits, and you don't know
immediately. Exactly. But this is literally, this is why I love this, like showing it this way. This is what we're asking our engineers. So when we say, hey, you're writing the service, how much is it going to cost? I have no idea.
Yeah,
I have no
100%.
idea. So now I got to do some stuff and go figure it out. Let's make it better. What is the difference between these two in terms of costs?
You cannot tell.
Even, like this, you can't even tell the difference between like what is the actual thing that is changed.
Yeah, but seriously,
there's a single digit change in here.
Oh yeah,
the
24.
left-hand side.
Oh yeah,
exactly, and
okay.
That's spot on. On the left, that bit of code costs about $319 a month. On the right-hand side, that's about $3,900 per month.
It's like 12 times the...
And the key difference is this is the real life examples of what we see. Engineer tried to change the 2 to a 4, but instead of changing, they added the 4. That is the only difference. And then what happens? That goes to production. As someone comes and screams at us. It's like, hey, how did you spend this much money? What happened? I'm like, there's nothing in here. And this is like the smallest block of code. Imagine a pull request, which has got thousands or hundreds of lines of code being changed. How do you do this? And 100%. So this is why I'm saying, like, this is the key point at which the prices need to be clear for the engineers. One layer of complexity. You remember that I talked about the complexity of this stuff? This is a chart that shows the live number of prices from AWS, Azure, and Google. So in 2012, it was a couple of thousand. In 2021, when we started this company, it was just hitting 3 million live price points. As of January, there are 10 million live price points, meaning depending on how you write your code and how you use something, a service, and what functionality or what features you've said, you will hit one of these prices. It is impossible to expect anyone to know this information.
Yeah, this is like my direct conclusion. It's not something that engineers can figure out on top of their head. They need a system or a mechanism to be able to catch any changes. Okay, curious for more.
Okay, so now before I show you the thing, because I love showing it live, but I don't like that many slides. But one thing I'll show you and like what makes this whole thing work is you have to have a context engine here for anything to work on top of. What does that mean by the context engine? The context engine has those 10 million live prices, so it knows what the current live price is, but also it has code analysis information in there. I'm talking about this yellow box right down here. Mm-hmm. Code analysis information means, for example, in Terraform, if you don't define your volume type, you get defaulted to a GP2. That has to be in the context engine of the system, so it can tell you, hold on, there's a GP3 available and it's cheaper. Then there's FinOps policies of like, hey, don't have HA systems in non-production environments, things like that. There's tagging. If you're getting to cloud cost management, allocation, showback, chargeback, we have to ensure that the tag keys and the values are validated. And then there's a lot of other things like org structure, cloud usage that we talked about as well, of like, hey, what's the performance of this thing? And then finally, engineering input, which is incredibly important as well, which is if I say, hey, this application will not work on Graviton, we should not alert you next time you touch an area of code to, hey, you could use Graviton. It's like, oh, I've already told you it doesn't work that way. So it has to learn these things. Does that make sense?
Yeah, quick question about the engineering input history. So what could that be? Or what could be the source of this?
So example, I'll give you a real life example. In GitHub, GitHub is the check pillar. So in dev is me on my machine. I'll open up VS Code and I'll show you. Okay. Check pillar is in GitHub. And then AI powered fix and find is the final part of like bringing the usage and things like that as well. So the check part, a clear example, says, hey, we should use Graviton instances for these services because they're a lot cheaper. An engineer might look at that, or an architect might look at that and say, hey, we can't use this application, will not run on Graviton chipsets. So what they can do is literally in GitHub say at Infracost, dismiss this issue. The reason is this application will not work on there. That goes into the context engine.
Okay.
So that anytime anyone touches that area of code again, it doesn't give the same recommendation. Key part, reduce noise. You can't have noisy output. So things like that.
Okay, makes sense.
Okay, can I show you it running live? Now the fun part. All right. If I close this screen and I open up VS Code. Share my screen. Okay. Can we see our VS Code? Perfect. Okay. So this is running live on my machine right now. I've got VS Code running. It works with JetBrains and things like that. There's a bunch of plugins. And I've got Infracost running here as well. So now you see every bit of infrastructure as code. So Terraform, CloudFormation, things like that, shows you, here's how much this block of code is going to cost. So let's do this live. So I've got a M5 8XL right now. This is going to cost about this much. What would happen if I change it to a 4XL? And just before I click save, look over here, and I'm going to click save. If the demo gods are good, there we go. Immediate feedback. So now the engineer is learning, that is this price. And so this obviously is a super easy example, so you can get to see it, but you don't need to go to a calculator. You don't need to go anywhere. Immediate feedback is directly built within your dev machine and your dev environment. But also from the context engine, it has things like this, which it says, hey, I also see you're using IO1 as an EBS volume. If you change it to GP3, it saves us about $100. Plus, there's no downtime. And without stopping the instance, so the context is already there of like, hey, this is all that you need to know. And here's the ADBS docs if you want more detailed. This is another key principle. It has to be in workflow. So let's take this. Let's take the GP3, put it here. Let's save. That issue is now gone, and we've reduced it by another $100. This is literally learning live. So engineers can start to actually really quickly start to fix a lot of these issues.
So yeah, you are bringing the FinOps awareness to engineers where they work. It's like
where they work.
Yeah.
And pre-launch. So it can be, by the way, this could be also launched as well. This could be your current Terraform file. Yeah. So exactly, it's directly in the workflow right there. Now, a couple of, by the way, final thing. So if you have tagging issues, this is the exact same thing. So it validates the value. It says, hey, you're using prod. Actually, it should probably be production. So look, if I do this and I save, boom, another issue gone. This is how quickly you start to get fixes. But about 6 or 7 months ago, we started seeing something weird. We started to see application code fine was generated with AI. We started to see infrastructure code being generated with AI.
That was my next question. Is like, okay, this code has written by an engineer that knows what he or she wants to build, but now we are having like AI and AA agent building the code based on the application requirement. So how can you challenge this?
And you're exactly like, if I keep going down that path, it's like, this is too late. Like the AI just wrote so many files. Like, why am I showing me this?
And you paid for the tokens.
Yeah, and you've already sent the tokens. So spot on. Okay, I'm going to open Claude. I like using Claude directly in my VS Code. So let's open Claude. Here we go. So FYI, Fable 5 is back. So let's waste some tokens. All right. So now let's say create me a 3-tier web app with Terraform. So I'm going to ask Claude to do it. I now have an immediate integration into Claude where it says, hopefully, there it is. Okay. As soon as Claude thinks, it's like, okay, actually, I'm going to generate any infrastructure. I'm going to touch infrastructure. The first thing I need to go do is go to that context engine and bring that context engine in. And that is what this is. It triggers it from the start. So as it even writes any code, it makes sure that the context is already there.
Okay, I see.
So all the infrastructure is going to be tagged properly from the start. It's going to be follow best practices. It's going to be optimized. It's going to be within budgets. If it isn't within budgets, it'll tell you, hey, I cannot do this within budget. So FYI, you have to tell your manager or whatever. So this is like how easily it is to get into the workflow. 2 cool things I'll geek out with everyone on here. In order for this to work, because it's those 10 million live prices, it has to be deterministic. You can't say one time, hey, it's going to be $10, another time it's going to be $100. It has to be deterministic. So the way we've done it is via CLI wrapped approach, which makes sure that ensures every single time it is deterministic. So that's awesome. If you're building something like this, that's a good approach. The second part to geek out on is because we know how much tokens are being wasted here. The CLI actually makes sure that the Claude is compressing the kind of input and output and things like that. By using this, we use about 70% fewer tokens. There's less retries. There's like everything's fixed from the start. So it's an incredible saver of time and money and tokens as well this way, directly in here.
Yeah. We see. And so And so for engineers building, so I have like too many questions in my head. The first one is,
Yeah.
so the first one is when engineers with infrastructure background build the infrastructure, they have kind of mechanisms and FinOps awareness way of writing, asking the question to generate the code versus when a developer asks,
Mm.
or when I say developer is like just an archetype for someone who doesn't deal with infrastructure on databases. There are also a lot of details in terms of, okay, I may choose, AI may suggest something that is cost effective and good, but may trigger later a lot of troubleshooting when you need to maintain the infrastructure, especially, sorry, especially that maybe the SRE team, which is a different team, will be maintaining the infrastructure, not the initial team that build the first version of the infrastructure. So how do you
Yeah.
see these different populations working together?
100%. Okay. And in larger enterprises, it gets more and more complicated because it's got multiple different tiers and layers and things like that. That context is incredibly important. Given we didn't have enough time, I won't show you a third pillar, but basically that context all gets built in. So when an architect actually says, one of the best ways that I've seen it done. So architect says, here's the system we're going to design, here's the constraints, and here's what we're thinking about. That goes into a Jira ticket. The AI system picks up that Jira ticket and creates the initial version following those best practices. But then the engineer actually is seeing it and inputting back in, hey, these things I've got to change. I have to do it this way, that way, whatever. That then goes back into the information section so that when the SRE team comes along and something's gone wrong, they can see the trail of actually what happened from an architect perspective to the engineer writing it to the pull request at what happened, and then the SRE picks it up. That has traditionally been tribal knowledge in people's heads. More and more, it is now in systems, which is incredibly helpful. You have the architecture diagram. You have to follow from that. One of the cool things another customer does is compares from the architecture diagram to the pull request. What is the difference between these 2 points? If it's changed significantly, we need to make sure we're aligned before anything goes live. So there's a lot of systems and processes like that get built in that provide those safety nets.
100%. And this feedback loop, so do they feedback the input, what you call the engineer's input system, or how do they take any feedback and feed it back into the global context?
Yeah. Companies are doing it differently right now. Like it's wobbly ground for sure. Like there's many companies doing very different ways. So there's not, I'd say, a unique solution right now for it. A lot of companies want to keep those knowledge bases in existing systems that they already have. So usually I see it go into a Jira system. So anything that's been used to generate those pushed back into Jira. At the same time, you need that in the context engine for FinOps for Infracost to work. So that's also it automatically directly gets fed into Infracost, but also it can be distributed anywhere else as well. And usually that goes into another system. I believe we should get to a place where there will be context engines inside companies for different things. And that's very important so that the systems, when they're talking together, they have the context of what the basis of the history was. One cool additional part, context can be true at the point that it was written, and it can be false by the time you're looking at it.
That's true. Yeah.
So yeah, you know what I mean? So a clear example of this that I give that is very interesting is when AWS launched GP3 volumes, about 95% of the time it worked. 5% of the time it did not work. Like you could not migrate to that. So initially, the context engine was fed with a lot of things like, hey, this won't work on GP3, so I can't use GP3, blah, blah. So it started dismissing, ignoring these issues and stuff like that. Fast forward 6 months, AWS had updated GP3, 99.9% hot swappable, 20% cheaper. So now you need to go back to the context engine in a very easy way and say, remove all these dismissed issues. I'm going to provide you more context, which is like, now you should retry. So the next time an engineer touches that area of code, it says, hold on, there's been an update. Can you have a look and see if you can do this? And that system, so what I mean by that is that system has to be live. It has
Okay.
to keep live systems in Ocean.
And this will feed the context with live information, whatever the changes are. Okay.
Spot on. That's
it. Makes a lot of
So
sense.
reduces noise, focuses people on action. A lot of those key principles have to be built in that way.
Okay. And what are the best champions within organization that you think are like best champions, or the ones that are advocating for FinOps?
I remember, this is a great question. I remember when we went to YC, one of Michael Seibel's questions to us was, hey, engineers don't traditionally care about cloud costs. Like that's common knowledge, no?
Yeah.
So why are people using your product? Like, why are they pulling it? Why are they installing it? And so like they're engineers, right? We're like, yeah. So we went on this journey of discovery. There are about, I'd say, 10% of engineers who are optimizers. They love the optimization game. It doesn't matter, have to be cost. It could be performance. It could be latency. It could be whatever it is. And they love it. They're one of the best ones to focus on these kind of activities because they lead the charge to show everyone else how easy it is. And so everyone else starts to learn and pull along. So they're that kind of persona. The second best, say again.
I said these are the bees spreading the pollen.
Spot on. That's a really good example. I might have to use that for in the future. That's exactly right. Because I just showed you how easy it is. So some of the people watching, they'll be like, actually, I can literally set this up in 5 minutes. Let me try it. And so you start to have that, and then you demo it to other people, and other people are like, whoa, I did. So that's the kind of rolling that starts. The other best group of people are people who are in charge of platform teams. So the platform team sets up the guardrails and the infrastructure, the frameworks that we should live by when we're designing systems. So you can then imagine with our GitHub integration, you can do everything I showed you directly in GitHub when a pull request is opened, and it shows you the diff. So the platform team can say, oh, that pillar, here's how I'm going to set up that pillar for costs. I already have security. I have code linting. So those are the best ones to get mass distribution in a large enterprise company.
Okay, I see. And we're talking about AI because like the AI is everywhere in the conversation, even for like basic concepts and examples, which is great. So like now we have, I feel and I see that like there is a new vertical in FinOps, which is AI. Mm-hmm. And like how should we deal about it, and what's its role in the whole costs concept and FinOps concept? Yeah, and I know that recently FinOps Foundation created another foundation for tokens. So yeah, what's going on?
The Tokenomics Foundation. Yes. I feel like we could do a whole other episode about this. Okay, so I'll do a very high level what's happening. When it comes to token consumption and AI costs, there are two ways to split it overall, to think about it, kind of thing. There's internal consumption of tokens, and there's external consumption of tokens, which is used for your customers. So let's take a good example. Random company, Coca-Cola. Internally, they might use a lot of tokens to generate code, to generate PowerPoint slides, to generate anything that is being used internally for the company's internal operations. But also there is, hey, generate yourself, for external users, generate yourself a picture of you with Coca-Cola. That has token consumption for an external. No. So those are the two ways to separate these things out first. The first one currently, I'd say, is the majority. However, there's a humongous wave that is going to happen on the outside as well, on this side. So there's, like, if you're thinking about startups, this is an incredible place to kind of look at and think about. On the internal consumption part, it gets into the details of like prompt engineering, of like how do you compression, how do you do smart model routing and things like that. And then external part is like model selection, deciding between speed and performance and things like that are out for the external parts. I say these things to paint a picture of why I think the Tokenomics Foundation is an interesting part, because these questions are moving incredibly quickly, and the answers will vary and it will change very quickly. So you need a dedicated set of people to work, a startup within a startup mentality. And
Yeah.
this is why I think this is needed at this point.
And in terms of tooling, what do you see around? Because when we talk about the costs, like the costs in the cloud or on-prem, we have some tools in mind because the workflow is clear. I have the design translated into code. This code, I can analyze it for costs. I have like a precise picture, decide whether it's okay or not, deploy and monitor like that.
Yeah.
It's pretty simple. But for the AI, is like I feel that there is, and it's changing a lot. So how FinOps fits in this process?
This is where the Tokenomics Foundation is trying to define it in a better way, so people can share best practices and can share kind of what we're learning together. But you're completely right. If we're using AI to generate the first architectures and systems and things like that, that token is going to get consumed and go. So like there is no process. It's just from the start. It is that kind of thing. So there's multiple ways that people are approaching this, and we don't know which one will work and which one will not. But for example, a system that sits on everyone's machine that measures how many tokens are being used, and what for. Like, what are these tokens actually being towards? Categories, not like, oh, he's doing this, but like categories of things that the tokens are being used for, to give more visibility to see what we can do. However, your next question can be even more interesting, which is like, imagine you created a PowerPoint slide for sales using AI, using Claude Cowork, let's say, and I used my own time and I did it manually. We both now have PowerPoint slides. That's not the value. The value is who managed to sell the deal using that PowerPoint slide. How do you measure that? How do you yeah, exactly. Like, what do you do with the output of that? Is there a value? Or the other discussion is like, here's how an easier way to measure the value. Go to your employees and say you cannot use AI anymore, and see how many of them leave. So it's like, right, you see what I mean in terms of like the extreme way of thinking about this is like, once you start to think about the value, it might go down the first route of like, hey, let's actually measure the value, or the second route, hey, you need a laptop to work.
But I go back to the engineers, and like from the engineering point of view, like if you tell me, if we take any concepts like the compaction, and you tell me that if you compact, you may save 70 or 50% of the tokens. Yes. So like the thinking process would be, okay, how can I optimize the compaction in a way that I don't lose the message, but I still have, I still profit from the compaction, which is most of the time is handled by the LLM providers themselves.
Right.
So yeah, what is left for the engineers to how you say, to engineer to make it work?
I'd argue actually first, it probably should not be up to every single engineer in a company to make that, like, to try and do that, because like they're trying to create value for the end customer of their company. So I think it should be a force group. So this is a focus group. I'm sorry. What I see the best companies do is put specific people in charge of like, how do we do this exactly with like a proxy layer. So can we do a proxy layer in which like we handle these from a central place and we measure and we iterate and stuff like that, kind of like how platform teams came to be, of like managing, you know what I mean, in terms of like the IC and enablement of self-service. I see something similar in the AI space. Like you could also do that, which is like some very special cloud. We've had this multiple times, right? Cloud Center of Excellence. Yeah. So we have AI teams being set up which try these things and say, do or do not do it this way. But you're completely right in the other question, which is, yes, the exactly the same thing as early days of cloud. The cloud providers chased and fixed many of these issues also. It just took them a long time. Let's see if the LLM providers, they currently don't, right? They don't have solutions for this. So, and the other thing I'd layer on top, which is very different to cloud, I think early on in the cloud was very clearly AWS, it was single cloud provider. Very early on in AI, it's multi-provider. So it is not just one. Therefore, I think there's space to do a lot more here.
Yeah, absolutely. And so, and doing the devil's advocate, going back to the FinOps, what do you see as the blind spot of the FinOps as a context, as a concept, but also as it is implemented technically within teams and companies?
Yeah. Do you mean within the AI world, or do you mean
no,
in
independent of AI? Is like in general, like when we talk about FinOps and costs in the cloud, not just in the cloud, managing the cloud infrastructure, because I would love to ask about the on-prem as well, but let's keep it for another question. So yeah, what's the blind spot of it?
I wouldn't say blind spot. Here's what I would say the biggest challenge is, which is ultimately, if you have a set of recommendations that need to be actioned, and you have 3,000, 4,000, 5,000 engineers doing these actions. I'll give you a good example. Estee Lauder, one of our customers, we were on stage together. They are making, I think it was like 13 infrastructure changes every single day. The infrastructure is being changed 13 times every single day by about 400 engineers across the board. So different engineers will do different days, of course, like that. So one of the biggest challenges is, how do you action these things that you want to action, that you can optimize your costs and improve performance and things like that in such a decentralized model? You need tools, you need automations, you need to put this in the workflow of the engineers. Like all these concepts are basically exactly that. So this is one of the challenges, which is then you can just show an engineer, but what if they don't take action? And then ultimately, you're coming all the way around back to your first questions of the first part of the chat. Measure the impact. What was the ROI? So literally, that's how we measure it. We say when a pull request was opened first, let's say it costs $10,000. The engineer saw it and they reduced it to $8,000 and then merged the code. That's preventing or avoiding $2,000. You should celebrate that engineer. It's culture change, which is like, hey, we see it, we value it, and so we celebrate it as well. And so there's a lot of human aspects to this whole project as well. As soon as you have multi-personas involved, humans are going to get involved as well. So that's the kind of biggest challenges that are there.
And a related question, because I'm maybe biased based on the customers that we work with or the engineers that we work with. When there is, when you say pull request, there is a change, there is like an impact in terms of pricing, and the engineer has to take a decision. So who usually take the decision and the responsibility of the decision? Is it the same person, different person? Do they ask different?
Love it. Let's make it more extreme. Let's say I'm designing a system and we literally had this, and the cost comes out to $550,000 a month. This is a real life example. I've taken a screenshot from my LinkedIn and put this in. That's a $6.6 million pull request per year. What happens? So naturally, we have a system that says, "Hold on, whoa, we're about to spend $6 million." The alerts go out to the budget owner. So this is the application budget owner, to the FinOps team, and the engineer sees it in the pull request. The conversation after it was incredibly important, which is they came back in, they were like, "Whoa, what has this changed?" And the engineer says, "This is the Jira ticket. I'm working off the Jira. Like, this is what the requirements are." And the key thing is, it was not the fault of the engineer, because in the Jira ticket, it says this system should scale for 1 million concurrent users. The product owner came in and said, "Wait, hold on. That doesn't mean 1 million users now. I meant that in 3 years' time." It's like, that's not what the Jira ticket says. So there is no fault, right? There is just like the communication is incredibly important. And we don't need to go to a war room after it's gone live. We can prevent it. So I use that example as a very interesting part, which is the ownership is not with the engineer, is not with the applicator, it's a collective ownership. As long as these discussions are happening and we're designing the best way, that's good. Now, let's turn that situation into yes, we need it right now, and it's $6.6 million. The budget owner should tell the FinOps team, "Hey, we're going to break the forecast because this change is needed, and here's the approvals. Everyone's aware. Yes, now it goes live. The bill goes up. There's no alerts. Everyone's expecting it." That's the building together.
And here where I see a gap, because when you said as long as these conversations or this conversation is happening, so like what if these conversations are not happening, or the system is not designed for these kind of communications? Like I have a Jira ticket, I'm an MSP, like, I'm going into the
Yeah,
cliche,
yeah,
the
yeah, yeah.
extreme. I'm an MSP, I got a ticket, I have to deliver because I'm paid based on the outcome, on the output.
Yeah.
Okay, I implement the change, merge it, and that's done, end of my day.
Yeah.
So yeah, in this scenario, it's like, what's
Great question. Okay, there's two different types of pull requests that I see, and what I call them are burst pipes and leaky faucets. When a burst pipe happens, everyone sees it. They're like, "Whoa, there's a burst pipe." The $6.6 million change, that's a burst pipe. Everyone's seeing it. Everyone jump in. Let's figure it out. Talk about it. Blah blah. But you're completely right. The other part is leaky faucets. One or two drops, no one sees it, but there's hundreds or maybe thousands of them everywhere. And this is where you implement the best practice policies within there. So there's two main things you could do. You could say, hey, these are the policies that we need to abide by. But also, two, is this is the budget of this application area. As changes come in, the total budget is burning down, and we see it. And you can visibly, I should show you the product, but we literally see every single pull request and the cost impact of the pull request in a central dashboard. And so the application owner can go and see my application and the budget owner and say, oh, yeah, the MSP is doing like 50 changes. Each one is $200. I got to chat about them. So you start to see the leaky faucets. Once you see it, you start to action it as well.
okay? That makes sense. All right. Yeah, it's been like 50 minutes that we are talking.
Oh, wow.
Yeah, or anything that we missed talking about. I know that you have a lot of things about DevOps, and every time I talk to you, I learn new things. So anything that engineers should care about that we didn't talk about?
I think we covered everything. We covered pretty broad. I think the key thing for engineers right now is the practice of leaning in. If you lean into cloud costs, you start to get very high visibility inside a company very quickly. Like and this is one of the things we learned early on at Infracost in YC days, which was when you do a practice like this and you demo it to an inside the company, much senior execs take note. They're like, whoa, because it's directly related to the bottom line of the company. It has a very direct connection. So there's a lot of things you could do, even on your day-to-day work. So that's a very interesting position to be in right now.
Perfect. Hassan, thank you very much for all the insights and for also taking the time going into specific question and explaining thoroughly. I highly appreciate it. It's always a pleasure to talk to you. So anyone who is interested in FinOps cost optimization in the cloud, Hassan, you have guys, you have his LinkedIn. He's a friendly guy. Just ping him on LinkedIn. And all right.
Always open. Dude, every time we chat, I enjoy it. I didn't even realize we were talking for 50 minutes.
Absolutely. Hassan, enjoy the rest of your day. Thanks, everyone. Talk to you soon.
Cheers, team. Bye.
Yes.